This question comes from Bay Area JavaScript interview prep meetup on August 2nd. Given a 2D array with sorted integers and a target integer, so this is a 2D array. Every row and column is sorted, so 1, 5, 9, 20, 25, 3, 7, 10, 21, 26, 1, 3, 4, 6, 7. But each row are not continuous, so your 25 does not continue until the next row. Each column is also not continuous. 1, 3, 4, 6, 7 does not continue until the next column. Return true if the target exists. So if you have a target of 26, you return true. If your target is, let's say, 99, then it is false. Pause the video and see if you can solve it. What is the brute force solution? The brute force solution, well, it's n squared, right? If assuming row is n. Well, let's first assume the row and column is the same, both are n. If you brute force it, it's n squared. Now, we all know if we want to search for something that is sorted, it is a log of n because we use binary search. How do we get less than n squared? We just binary search on every row, right? So this is a log of n, log of n, log of n, log of n. So you log of n times, you get n log n. This is a Facebook interview question. This seems too easy, isn't it? So if you want to be fancy, you can also say, well, if your row and column are different, you can m log n or n log m. In the end, you can just say you just do binary search on the, you can do binary search on the longer side, right? If you do binary search on the longer side, each longer side will be log of that longer side. Then your outer loop will be the shorter side. So it will be shorter side log longer side. But that is not much of an improvement. A Facebook interview question is expecting you to find a linear solution. So if you did not think of that, pause the video again and see if you can find a linear solution. What is a linear solution? For us to find a linear solution, we can expect us to do some sort of a walk. And every time we do a walk, for example, you go right, go down, or you go left or go up, we should ideally be able to eliminate a row or a column. Let's say if we start off from 1, let's say we are looking for 22, okay? If we start off from here, do we know we should go right or go down? No, we don't know, because in both directions, you are going up. Now, if we start off in the rightmost corner, and we are still looking for 22, do we know in what direction shall we walk? Well, 22 is less than myself. Of course, if we are looking for 25, you return true straight away. Now, we are looking for 22, which is smaller. Do we go down or we go left? Because your column is always sorted, so if you go down, you're definitely looking up. So if you want to look down, you definitely go left, right? Assuming we are looking for 22. Now, when we are here, is 22 greater than me or smaller than me? It's greater than me, right? So if you go down, if you go left, you're definitely going down. So you need to go up. Same thing, is 22 greater than me? Yes, so you go up. Now, what is the worst time complexity here? The worst time complexity, it will be, you will go all the way, right? You will go all the way from one corner to the other corner. By the way, you can also start off here, it doesn't matter. Because both of these two corners, bottom left and top right, you can eliminate a row at every move. You can eliminate a row or column at every move. So your worst time will be you're looking for 7, or your number doesn't, okay, there's a 7 here. Well, you get my point. Let's if you make it 6, right? If you make it 6, we will 7 is your worst time. So your worst time will be all of max mn, right? Assuming m is your row number and your n is your column number. So let's just walk through. If we want to look for 7, 7 you need to go down, go down, go down. Then from here, you need to go up, you need to go up, right? But then you need to go down, then you need to go up, then you need to go up. Then you found it. Now the code itself should be very easy. So I'm not even gonna code it up with you. I'm just gonna flash the solution. So this is log n, right? Your C stands for column. Your row, your R stands for row. You first loop, you loop through the row, so you have a linear time complexity here. So you can do an optimization. So this is a constant time check. You check whether your target is inside the range, right? Whether you compare with the first element of that row and the last element of that row. If it's inside the range, you do a binary search. So this is our standard binary search. If you can find, return true. If you cannot, return false. Okay, so this is the linear time complexity solution. Yeah, so you start off at the rightmost corner. So your row is 0, your column is the rightmost row. So this is the bound. Once you exit the bound, you return false. If my number is greater than target, I need to go left, else I need to go down. So there we go.